So this week we'll be looking at separating a mixture. So you come down here and click, and you'll see the module overview, and this is the assignment. View the assessment, and these are your instructions. You'll need to download this outline, and it will look like this. And then you'll need to go to your lab. First, I want you to make sure that you read these instructions. They tell you about separation techniques, types of techniques, and their related property. Every time we separate two things, they are being separated on the base of a physical property. You should know what those properties are. This will make your background, if you'll read this, make your background section awesome. Then when you get ready to start the lab, we'll come down here and push this, and you'll get your instructions. This is your procedure. You need to summarize the procedure in your lab. I do not want to cut and paste. I will not give credit for cut and paste, and I want you to summarize. It doesn't have to be long, but it does need to include all the steps. All right, so now you're ready to do your lab. You'll come to here, and we'll need to push that, and then you'll want to open this in a new tab. That'll allow you to switch back and forth between the procedure and the simulation. So there's the simulation. I kind of started it, played with it. All right, let's look at the lab handout here. So this is a format that you should be used to by now. We'll have a 2-point purpose. I want 2 or 3 complete sentences explaining why we're doing the lab. This is that background section I was telling you about. If you'll read the background that goes with your lab, you'll have what it takes to make a really nice background section. The procedure needs to be summarized. It should be short. Particularly with this kind of a separation procedure, you might use a diagram instead of a lot of words. That works too. Okay, so here's our data and calculations. I have your usual warning to record all digits from the balance and make sure you're recording the appropriate number of significant figures for all your calculations. So the first thing you'll do is weigh the empty evaporating dish and record it on this paper. Then you'll add about 10 grams of powder mixture A. And the mixtures are the compounds, I believe, are on the second shelf. Oh, goodness. They're right here. And the powdered mixture A is all the way at the end. Here's mixture B, here's mixture A. When it starts, it's all the way down here. Lots of stuff to look through. Okay, back to this. All right. Then we need to calculate the mass of the powder mixture that you started with. So if you'll take the mass of the evaporating dish with the powder mixture and subtract off the mass of the empty evaporating dish, you'll get the mass of the powder mixture. All right, then you're going to heat the powdered mixture. When you do that, the aluminum chloride will sublimate. That means that the aluminum chloride will go from being a solid into being a gas. So it'll gas off. It won't be in the dish after it's heated. So we mass the evaporating dish and contents after heating. And then when we want to calculate the amount of aluminum chloride, what we can do is we can subtract the mass of the evaporating dish and contents after heating from the mass of the evaporating dish and powder before heating. So this is the amount after, and this is the mass of the evaporating dish and the powder before. So you subtract those two numbers and put that here. Then we'll need to calculate the percent of aluminum chloride. And to do that, we'll take the mass that we calculated here and divide it by the total mass of the powder mixture, which is a third number right here. All right, then you'll you'll transfer the mixture to a weighed beaker. So you'll weigh your beaker first. Beakers in the virtual world all weigh the same. So the mass of the empty beaker here will be the same as the mass of the empty beaker down here in part 3. So we have the mass of the empty beaker and the mass of the beaker with the sand after decanting. So you'll put the sand in, you'll put the mixture in, you're going to add some water to it, and then you'll stir it up and pour the water out. What's going to happen is that the sodium chloride will dissolve in the water, and you will be separating the sand from the sodium chloride when you pour it out. When you pour the liquid out, the liquid is going to have all the sodium chloride in it. Okay, so we've got the empty beaker, we've got the mass of the beaker with the sand after decanting, and if you were in a real lab, you'd have to dry it. You subtract those two, and we'll get the mass of the sand. Okay. Then we want the percent of sand in the sample. We'll put the mass of the sand and divide it by the mass of the powder mixture. Remember, the powder mixture is the mass that you started with. It's all the way up here. So now you've got kind of salty water in the second beaker, and you're going to boil the water away, and then we'll weigh that beaker. And we can then calculate the mass of the salt by subtracting the mass of the beaker with the salt after the water's been boiled away, minus the mass of the empty beaker. And we'll do the same thing to calculate the percent of salt. We'll take the mass of the salt that's right here and divide it by the mass of the powdered mixture you started with, which is up here. Okay? So these calculations could be a little confusing. If you want me to look them over, I will be glad to. And if you've done this correctly, your percentages from each of these tables will add up to 100%. Now, in all things there is error. So I just made up some numbers, and we said that the accepted or true value of the mixture is not what you got. It's really 6% aluminum chloride, 60% sand, and 34% salt. And I want you to calculate your percent error. So the accepted value, or the values that I'm giving you up here, your calculated value is the value from your table. So for salt, you would use 34% as your accepted, and whatever you got in this box as your calculated. And calculate your percent error, and then come up with a really nice conclusion. Okay? And let me know if you have any problems and if you don't understand anything.